Hi, and welcome back to this first video in the sixth lecture on Covidenomics. What we're going to look at in this video is what I'll call a stylised fact. A stylised fact is something that comes out of a data but isn't perfectly true. It seems to be a regularity that holds, albeit subject to shocks, subject to differences between countries. So what is this stylised fact? Well, it's that while the initial reproduction number for COVID-19 seems to start at around 2.5 to 3.5, the effective reproduction number in many countries and in many places goes pretty close to 1 and stays around that level for quite long periods of time, in some cases months. So that means that you get to a point where the number of daily infections stays pretty constant. It may be a couple of hundred a day, it may be a couple of thousand a day. It may be in the tens of thousands a day, but it's fairly constant. So it may be 6,000 a day, 6,000 tomorrow, 6,000 the day after, to pick some numbers, for example, from India. It does get altered by government policy. We see where there are very strong lockdowns that this doesn't hold, that the reproduction number goes back less than 1. But for example, we've seen in Europe when the government policies come off, that the reproduction number, the effective reproduction number, tends to go back up to 1. So in that sense, again, it seems to be robust to changes when government policy comes off. It seems to occur in Asia, in Europe, in the US. So it again seems to be robust to culture. So we're going to look at the data first, just to try and convince you that this is in fact a stylised fact, and then we're going to think about some explanations. All the data that I'm going to present here is from epiforecast.io, and what they do is they put a 50% and a 90% confidence interval, so the outer grey bands of a 90% confidence interval, the 50% confidence interval is the darker grey bands. And here's our first example, so Portugal, a European country. You'll notice that the effective reproduction number, it starts up here around about 2, comes down and stays pretty constant around 1. Here we've got Poland, again gets down to about 1 in early April and is still going along at about 1 come early July. Here we have Sweden, quite deliberately chosen because of course Sweden, as we've mentioned a few times, has been a country that's followed different policies, different government policies for COVID-19 than we've seen in a lot of other countries, including most European countries. So here, Sweden, do we see something different for a country that has different government policies? Well, not really. We start up here at around 2. It comes down by early April. It again is the effective reproduction numbers running at about 1. Blips up, a bit of a blip down, but again, by July, early July, we're still around about 1 in that effective reproduction number. United Kingdom, if you remember, the United Kingdom has been criticised for being slow to act, has the highest level of deaths in Europe. So does it look different? Well, again, not really. We've got a situation where the effective reproduction numbers come down to about 1 by early April. It tends to go a bit below 1. That may be reflecting the lockdown conditions that they had in the UK. But again, it seems to be bopping around 1 without a great deal of movement once it gets there. The USA has, of course, had very, very different policies across the country. Same sort of pattern, though. Again, the effective reproduction number starts a bit above 2. Early April, it's down around 1. There's a blip up in early June, but by about July 6, it looks like it's coming back down again to 1. But again, subject to some blips around 1, it's not varying hugely from that level of 1. Now, as we said, the US followed very different policies in very different in their different states. So here's a few examples. We've got Georgia, we've got California, and we've got Texas. And yes, there's clearly some deviations. Both Texas and Georgia have bumps up around middle of June to an effective reproduction number greater than 1. But again, it's probably the pattern that's represented by this stylised fact that seems to be pretty amazing. We don't get jumps back up to 2, for example, in these states. Even as policies change, as mask wearing comes in, as there's different lockdown structures between the states, we seem to be around this effective reproduction number of 1. Just to check on the northern neighbours of the US, again, who have followed a very different strategy to the US, same sort of pattern, down to around 1 this stage at the end of March, and again, staying around there pretty much for the length of this graph up until almost the end of July. Let's look at another country that has been considered a very poor performer in dealing with COVID-19, and that's Brazil. And Brazil, yeah, you can say, look, they took a lot longer to get down towards this 1. We're talking about early June before we get the effective reproduction number down to about 1. But again, it's this downward trend. It doesn't stay up at that initial reproduction number. So if we're talking about initial reproduction number of 2, well, it tends to trend down, albeit slowly in Brazil, and comes down to this level of 1. South Korea, again, deliberately chosen. South Korea has been a country with very aggressive test and trace, mask wearing, but limited constraints on the economy. And again, you get quite a bit of volatility happening around here. There haven't been a huge number of cases for most of this period in South Korea because they're considered a success story. But again, you can see that you sort of get down pretty quickly in South Korea. Really, beginning of March, you're already under 1. Then you tend to bop around 1, following on from around the end of April through to the end of June in this graph. India, what have we got there? The effective reproduction number really hasn't come down to 1 in India. I said at the beginning 6,000 cases a day. I should have said 60,000 cases a day. That's where we're sitting at the moment with the data that's available at the time I'm making this video. But again, you certainly see this initial reproduction number changing. Probably India's the least convincing of the stylised fact countries here because it never really gets to 1 and it's really just starting off at a bit above 1.5 initially. So a lot less of this trend here in India of getting down to 1. So there seems to be this tendency in a range of countries, range of areas, for the effective reproduction number to move towards 1 and stay around about 1. Yes, it differs between countries, but remember, this isn't a fact, this is a stylised fact. This is something we see in the data that needs explaining. And it's obviously incredibly important because there's going to be big differences between a country which has an effective reproduction rate of 1.5 or even 1.2 compared to a country where the effective reproduction rate, the effective reproduction number goes down to about 1 and stays there. They're going to have very different experiences of the virus. So what could our explanations be? Well, here's the first one. It could be the case that the problem is actually at the beginning of the pandemic and measuring the effective reproduction number at the beginning of a pandemic. And maybe the actual reproduction number for COVID-19 is in fact 1, and maybe it just stays at 1, but for some reason it appears higher earlier on. That doesn't seem to be very convincing. I certainly haven't heard any of the epidemiologists claiming that, and this is very much the epidemiological argument. The epidemiologists seem to say, no, the initial reproduction number for COVID-19 is significantly higher than 1. It's much more infectious than 1, and we're probably looking at certainly somewhere above 2 for that initial reproduction number. So this doesn't seem to be a very good explanation. A second possibility that it's actually the government policies that are pushing the reproduction number to 1. That doesn't seem very likely. I've deliberately chosen a range of countries to show you the data here so that we can see a very, very wide range of government policies. And particularly, including countries like Sweden and the US in there, was quite deliberate to show that different government responses don't seem to have that much effect. If anything, government policy may be able to pull the actual reproduction number below 1 for periods of time, and then when they release those restrictions, it comes back up to 1. But there doesn't seem to be a lot of evidence from the data that it's government policies that are behind this stylised fact. The third explanation, and unsurprisingly the one that we're going to look at in the next few videos, is that this is actually this endogenous economic behaviour that we've talked about. The fact that people will change their behaviour because of the pandemic, and that it's actually this change in behaviour which is pushing the reproduction number to a level of about 1. We've talked briefly about the endogenous changes in behaviour in these videos. For example, we've looked at the Goolsby and Syverson work and noted that potentially a lot of the change in economic behaviour with the pandemic is an endogenous change. In fact, very little of it may be related to government policy. But we haven't followed that through to see what the implications are, and that's what we're going to be doing here. Why is this important? Well, two big reasons. Firstly, if endogenous changes in economic behaviour alter the virus effective reproduction number, then that will change the course of the virus. That will change our predictions about the number of people who will be infected, and the number of people who will die, and the time that it will take for the virus to pass through the community and reach herd immunity threshold. All of those things will be very, very different if this endogenous behaviour drives the reproduction number to 1 compared to, say, modelling of the virus on the standard SIR model with an initial reproduction number of, say, 2.5 or 3. The second reason why it's important is that it's going to impact government policy. Because if government policy impacts or has an effect on individuals' behaviour, then it's going to change this endogenous economic behaviour. And as it changes that behaviour, that may impact the effects of the policy itself. In other words, there may be either feedback effects from the policy, where the policy changes behaviour in a way that actually offsets the policy, or there may be strengthenings. A particular policy may lead to changes in behaviour that back up the policy and make the policy much more successful than it otherwise would be. So we need to think about the policy implications of this. Just to give an example of this importance, here we've modelled a few different numbers for total number of people infected over time. Remember, the way that we've been doing this in the earlier videos is we've been saying a period of time is the length of time that it takes for somebody to recover from the virus, so that our beta is our reproduction number, our initial reproduction number. So here we've got with the blue line a situation where the initial reproduction number is 3 for the virus. Pretty much everyone gets infected, and they get infected pretty quickly. In contrast, if we have an initial reproduction number of 1, then we've got the orange line here. The virus takes much longer to take off, and we get to herd immunity threshold well and truly with a tiny fraction of the population, around 10% of the population being infected here. What I've done with the grey line is I've made the reproduction number endogenous, in the sense that I've kept the effective reproduction number over time equal to 1. What happens, remember, with the standard SIR model is that you start off with an initial reproduction number of, say, 1, but as the share of a population who are susceptible to the virus drops, the effective reproduction number drops. So the grey line is when it's forced to be equal to 1, a bit like what we've seen from our stylised fact. The key here, though, is that if we're really in the grey or the orange world, for whatever reason, and not in the blue world, then there's a big, big difference. And if we're using our model of the blue world to predict infections and deaths, when we're really in the grey or orange world, then we're just going to be wrong. So in the next couple of videos, I'm going to be looking at a model of the course of the virus that incorporates this endogenous change in behaviour. Now, generally, they're really, really hard and complex. They're systems of dynamic equations that are well beyond my mathematical capabilities and well beyond the level of these videos. However, friend and colleague from Toronto, Joshua Gans, has a nice paper that sort of shortcuts it. So he's got a workable behavioural epidemiological model. It's this NBER working paper. And that's what I'm going to be using as the starting point. I'm actually going to simplify down Joshua's simplified model. So what I want you to do in the next few videos is not take the model literally, but take it as an example of how important it is to incorporate these behavioural changes and how they can impact policy. But we'll get to that in the next video.